Okay, so these notes are going to be about factoring. So to begin factoring, we're going to talk about what a greatest common factor, or GCF, is. In elementary school, and even in middle school, you would learn what a greatest common factor is, because that's how you add and subtract fractions. You had to find a common denominator. We generally would sometimes do that through greatest common factor. So just a refresher on that. If I asked you what the greatest common factor between 12 and 18 is, well, so you're looking for what are the factors of 12 that are also factors of 18. So I know that 1 times 12 is 12. Neither of those, 1, but 12 doesn't go into 18. That's not a factor. 3 times 4 is 12. 3 times 6 is 18, so maybe 3. But then I also know that 2 times 6 is 12, and 3 times 6 is 18. So the greatest common factor between these two would be 6, because 6 is the largest number that basically goes into both of those. So that's just a quick review on what GCF is from middle school and elementary. All right, so let's review first what we did earlier this week, and then we'll talk about how we find a greatest common factor. Okay, so just reviewing this, we would do a times 3a. That would give us 3a squared. A times 7 is plus 7a. Those are not like terms. I have a squared and a, can't do anything else. The next one, negative 2m times m squared would be negative 2m cubed. Negative 2m times 6m is minus 12m squared. Negative 2m times negative 1 would be plus 2m. So we distributed a negative 2m to all three pieces up here. We distributed a to both of those pieces. The last example here, we're distributing 5xy to both pieces. So 5xy times x is going to be 5x squared. Y, I already had an x. I distributed another x to it. Then 5xy times negative 2y is going to be negative 10xy squared. Okay, so that is distribution. So what is factoring? Factoring is like undistributing, where we are taking what they have in common out. So I'm going to write here, I'll say undistributing, and hopefully you understand what that means. So it's like it's undistributing. So when we distribute, I don't even know if undistributing is the right word, but when we distribute, we're multiplying. So when we're undistributing, we're dividing. So we are dividing out what they have in common. So what's in common? So we're finding what do all the pieces have in common that we can actually divide out. So if I went back to my examples here, now I'm going to be given this, so 3a squared plus 7a, and I'm going back to this. So I should be able to recognize, oh, these both have 1a. This one has 2, but this one only has 1, so both of them, I can take 1a out. So we take that a out, we put it back in the front, and then we put what's left over here. So basically, if I divided 3a squared by a and 7a by a, I would get 3a plus 7. So we're undoing what we did to get this answer. So again, undistributing, I think, is the best way to describe it. The ones that cannot be factored, so sometimes this happens, polynomials that cannot be factored are called prime. Just like numbers that only one in itself go into, then polynomials that cannot be factored are called prime. So it happens occasionally, not very often, but sometimes. Okay. This middle statement is really important. There will be several ways to factor. The approach we take depends on the polynomial, so it's not going to be the same thing every single time. Today we're going to start by using the greatest common factor. So we're going to factor the polynomials by finding the greatest common factor. You can always check your answers by just redistributing. So let's just get started here. So we have 3x plus 12. So I'm trying to decide what do 3x and 12, what factor do they have in common that I can divide out? Well, to get 3, I can only multiply 1 times 3. And to get 12, I can multiply 1 times 12. Dividing out of 1 doesn't change anything. So then I have to find a 3 if it's not prime. Well, I also know that 12 we can get 12 by doing 3 times 4. So 3 is a factor of both 3x and 12. So that is their greatest common factor is 3. So basically I'm going to divide out a 3. I'm going to put that 3 in the front. In parentheses, I'm putting what's left over. So when I divide 3x by 3, that gives me 1x. When I divide 12 by 3, I get plus 4. So I factored out a 3 from both 3x and 12. Now I want to check my answer, so I'm saying that this is my answer. If I want to check my answer, I would just redistribute and I should get the actual problem. So 3 times x plus 4. If I distribute, 3 times x is 3x. 3 times 4 is positive 12. So in fact, I did get the exact same thing. So I found that 3 was the greatest common factor. I'm going to go down this column. So number 3, we have 5x plus 30y. So I'm looking for what both of these have in common. This one has an x, this one has a y. Can't take a variable. 5 and 30, hopefully we know that 5 times 6 will give us 30, and this is 1 times 5. So the greatest common factor here would be 5. So we're dividing a 5 out of both of those pieces because that's its greatest common factor. When I divide 5 out of 5x, I'm left with x. When I divide 5 out of 30y, I'm left with plus 6y. Again, I can check my answer by redistributing. So if I have 5 times x plus 6y, 5 times x is 5x. 5 times 6y is plus 30y. So there we go. I got my problem again. All right. Number 5, 6a squared plus 27. So I'm looking for common factors between this 6a squared and 27. A squared, I don't have any a's over here, so I can't take out any variables. So factors of 6, 1 times 6. 6 doesn't go into 27. 2 times 3. 2 doesn't go into 27, but 3 does. So I can divide 3 out of both of these. So 6, and then we put that in the front. 6a squared divided by 3 would be 2a squared. 27 divided by 3 would be plus 9. I should definitely, if you get 2 even numbers here, you didn't take out the greatest common factor because you could still take out a 2. So that's really important that you recognize. Sometimes we'll take out a factor, divide out a factor, but we don't get the greatest common factor. So always check to make sure that both of these are not even. That would be the biggest hint to you that maybe your answer's not right. All right, so if I redistribute, so 3 times 2a squared plus 9. 3 times 2a squared is 6a squared. 3 times 9 is plus 27. Number 7, we have 21cd minus 3d. So I should notice right off the bat that they both have 1d that I can take out. I also have 21 and negative 3, so I want to know what is a common factor between 21 and 3. Well, 3 only has 1 times 3. So does 3 go into 21? Yes, it does. So their greatest common factor is actually going to be 3d. So we're dividing out 3d. We put that in the front, and then we actually divide this. So 21 divided by 3 is 7. D divided by D, these give you 1. Remember, we subtract the exponents when we're dividing, so that would give you D to the 0, which is just 1. So we are left with C, though. Minus 3D divided by 3D. What happens here? Students are like, oh, that all just goes away, and we're just left with 7C. That's not true. 3D divided by 3D is 1, so we're going to put minus 1. You have to leave something in that spot. If you don't leave something in that spot, when you multiply back out, you're not going to get a binomial. You would just get 3D times 7C and get the first piece, but you don't get the second piece. So if everything, what you would consider cancels, doesn't really cancel, that gives you 1. But if all goes away or cancels, then it's going to be a 1 here. All right, so next example, we have 15a squared b minus 30ab. So what I notice is this has an AB and this has a squared B. Well, I can't take 2 A's because this one doesn't have 2 to give. but I can't take 1a, and I can take 1b because both of them have a b as well. And then 15, I know that 1 times 15 is 15, and 2 times 15 is 30, so I can take out 15 also. So 15 is the greatest common factor as far as the number goes. So I'm going to divide by 15 for both of them, but I'm also going to divide by AB because they both have an AB that they can give. So 15, AB is our greatest common factor. We put that in front of the parentheses, and then our parentheses, we put what's left over. So 15 divided by 15 is 1. A squared divided by A, we subtract those exponents. So 2 minus 1 gives me 1A. B divided by B, that's 0. B to the 0 is 1. So basically cancels out again. Then we have negative 30 divided by 15. That's going to be minus 2. A divided by A is 1. B divided by B is 1. So those are all gone. So this A minus 2 is what is left over after I take 15AB from both pieces. Can check by redistributing. All right, AB minus A. Hopefully it's pretty clear to you that what they have in common is an A. So we're going to take out an A, put that in the front. We leave what's left over in the parentheses. So when I take an A out of A, again, I'm dividing it out. These give me 1. That would actually be A to the 0, and we know anything to the 0 is 1. So these go away, and I'm left with B minus A divided by A. So just like the one above a few minutes ago, we have to leave something here. So A divided by A, anything divided by itself is 1. You have to leave that there. Because if you multiply back out and you don't have this minus 1, you're just going to do A times B and get AB. Well, you have to somehow get a minus A, so A times negative 1 would be negative 1A, or just negative A. All right. So let's look at some that are a little bit more difficult. we'll go to the even side over here. So 14, we have 10x squared y squared minus 8xy. So I see they both have an x and a y, xy. This one has 2, this one has 2, but this one only has 1. So I can only take one x and one y because this one only has 1 to give. Then I'm trying to find what common factor do 10 and 8 have. They're both even, so 2 is definitely one of them, but I want to check and see if there's a bigger one. So 4 goes into 8, 4 doesn't go into 10. 6 doesn't go into either of them. 8 goes into 8, but 8 doesn't go into 10. 10 will go into 10, but not 8. So 2 is the largest number. So we're going to divide by 2 and x, y, because they both have one x and y that they can kind of give away, if you will. We divide this. So 10x squared y squared divided by 2xy. So 10 divided by 2 is 5. When we do x squared divided by x, remember we subtract these exponents. So 2 minus 1 is 1, so just x. Same thing on the y's. 2 minus 1 is 1. Minus 8 divided by 2 is 4. And this one gave away both the x and the y. This would be x to the 0, y to the 0, which is essentially just 1. So 2xy times 5xy minus 4. So in parentheses, we leave what's left over. Outside is what we took out. Number 16. I recognize immediately I have a 2, and a 4. So the greatest common factor as far as the number goes has to be 2. They're all even. I can take a 2 from every single one of them. So I'm going to divide out 2, 2, and 2. Then I want to look at the variables and see, do they all have a variable that they can give? This one has x squared, this one has x, this one has x. So this one has 2 x's to give, but these only have 1. So what I'm taking from every single one of them is just 1 x. So I'm going to take out an x. I'm dividing that out. Then I have y, y squared, and y. So these two, the one on the front and the end, both have 1 y. This one has 2. So I can only take 1 y from each of them because that's the most that this last term and this first term have to give. So 2xy is the greatest common factor. What we leave in the parentheses is what's left over. So 2 divided by 2 is 1. X squared divided by x is x. Y divided by y, 1. So again, these basically are like canceling out. They're 1, so they're not really canceling, but we don't have to write 1. Minus 2 divided by 2 is 1. X divided by x is 1. Y squared divided by y is y. Then this one, we have 4 divided by 2, that's positive, so that's going to be plus 2. X divided by x is 1. Y divided by y is 1. So there is what we have left over. These 3 pieces should not have anything in common if I took out the greatest common factor. All right, number 18, so 12, 36, and 6. So I can't take 36 and 12 out. I can only take a 6 out. I know 36 is divisible by 6, 12 is divisible by 6, so I can divide a 6 out of every single one of those. So we're going to divide each one of these by 6, 6. Okay, and then we have a to the 5th, a to the 4th, and a squared. So this is the smallest a, so I can take both of those. I can take 2 from here and 2 from here. You have to take what they have in common. So I can take a squared from each of them. Then we have b squared, b cubed, and b squared. So both of these have b squared. This one has 1 extra, but we can take 2 at least. So we're going to take out a b squared. So we're dividing out b squared. Dividing out b squared. So our greatest common factor is going to be 6a squared, b squared. Parentheses, we leave what's left over. 12 divided by 6 is 2. A to the 5th divided by a squared. 5 minus 2 is a cubed. Those give me 1. Minus 36 divided by 6 is 6. A to the 4th divided by a squared is a squared, because 4 minus 2 is 2. B cubed divided by b squared, 3 minus 2 is 1. So b minus 6 divided by 6 is 1. I don't need to write that. A squared divided by a squared is 1. B squared divided by b squared is 1. So I get 1, 1, and 1. So everything gives me 1. So now I do have to write a 1. I cannot leave nothing there. I have to put at least 1 to have it basically as a placeholder. Again, I would look at this. I cannot have anything in common between all 3 pieces. So this one has a cubed. This one still has a squared. This one doesn't have any a's though, so I still can't take any more out. So again, I could redistribute, so multiply this back out, and I should get back to my original problem. Okay, so we're going to do some more in class, and let me know if you have any questions or come in during when and ask for help.